Hello everyone. In this lecture, we're gonna discuss the Global Surface Water Mapping Layer, GRC, and so this dataset is a long time series. It starts from 1984 to 2022 at until today, and this is the image collection that stores this dataset. And there are multiple layers in this dataset. So as you can see here, occurrence, the frequency of water on any pixel, so from 0 to 100 percent. And the other layer is absolute change in occurrence between epochs. The first one is this, and the other one is since 2000, and the first one is from 1984 to 1999. You have seasonality, you have recurrence, transition, maximum extent. So for this example, we're gonna just look at only occurrence. So for any given pixel, we're gonna map the occurrence of water over that time period since 1984 to 2022. So let's get started. Actually, I'll just copy this image collection here, and then I'll create a variable, global surface water, something like that, and I'll just close my JavaScript statement and a semicolon. So this is the occurrence. So we're gonna select the occurrence data, which is the frequency with which water was present at a specific location and during that time period. So yeah, and so as I mentioned, we have multiple layers, right? So we have occurrence, change, absorption, seasonality, and maximum extent, what have you. So we're gonna use only this layer. So we have to filter that. So we're gonna create another variable saying occurrence. And so we're gonna say occurrence is equal to, we're gonna call this image collection here, and then we're gonna use the select function on Earth Engine, and then we can go ahead and this is the layer name, so we're gonna copy that here to just exactly print that. Okay, so instead of like the entire image collection, we're gonna map the occurrence data. So now we have selected our occurrence data. So let's just create a visualization parameter. So let's create vis params that stores the visualization parameter, and let's create a curly bracket here that stores our visualization parameter. So I'll define the minimum value is 0%. So it's this data ranges from 0 to 100 based on occurrence, water occurrence on any pixel or location. So we're gonna do the minimum 0 and maximum 100. And next thing is the color palette. We're gonna create a list of colors. So I would say red is 0, and then let's create blue is 100% occurrence, and that's about it. And let's close our curly bracket, and that's it. And then last bit is to actually display this water occurrence data at layer. Occurrence, let's just copy paste that our occurrence variable here, and then the next thing is we're gonna use the visualization parameter here. We're gonna use it here, and then last thing again is to create a layer name. Once we execute this code, we're gonna see a layer name here. So let's just name it water occurrence. All right. Okay, so okay, so we have a typo here. That's fine. Okay, let's just close our statement here. Now this will give us, this is a planetary scale, this is a global scale data. So for any given location, you can display the water occurrence starting from 1984. And another information that I would like to mention is this product is generated based on Landsat satellite data. So and then the spatial resolution is 30 meter, and this is a published work, and this product is generated based on Landsat satellite data. Okay, so let's go ahead and execute this, and here we go. So we have water occurrence data for any given location. So it's a global data. Anywhere you just assuming this is Great Plains in the U.S. Lake Michigan here. So you can say on water occurrence. So if you look at the the coloring, red is less frequent occurrence. That means it's not a permanent water area. So this is more like flooding, right? It occurs a pretty small amount of time. So that means this area was flooded, for example, whereas this is a permanent lake. So that's just one example of how you would interpret the data. We can also change the background to a satellite image background. So you can check and uncheck that water occurrence data. So you can see the purple or reddish areas are mostly flooded areas or seasonal water occurrence, whereas the dark blue is a more permanent river channel or a lake area. And this is you can zoom out and check in other areas. For example, this is Lake Victoria, and you can see the lake is pretty dark, so water was always available during that time. And then you can see some flooded area here, some wetlands, and so that's how you can, and then you can clip this by any given study area if you want to, but this is a global scale data, and that's how you can map water occurrence using the GRC global surface water dataset.